Right. So today we're going to talk about construction materials, all the materials that can be used for construction, and what are the different applications these materials have in construction. Uh, I mean, there are a huge number of materials that are involved in the modern day construction practice, but then there are few materials that are really commonly used out there on field, such as stone, brick, cement, concrete, also timber and steel as well. So these are the most common materials that we usually find on site, and apart from these, even modern materials, more composite materials are coming into picture, which involves a lot of fibers, which involves a lot of composite alloys and etc., that can be used for much more efficient construction. But then these are the fundamental materials that we are going to look upon in terms of construction practices. So when it comes to building materials, like I said, it's all about the materials that are widely used in construction practice, like stone, brick, sand, steel, cement, concrete, and glass is also a material that is used in construction, but then it's much more of an aesthetic material rather than of a structural material. But in general, as a construction material, even glass plays a very wide has a very wide contribution in construction practices. Next, aluminium and wood are also used as a very common construction material, but not as common as in the Asian countries. But then in countries with a much more cooler climate, timber is a very common construction material that is widely used. Even we use aluminium on a very common basis for the aluminium windows, aluminium door shutters, etc. So out of all these construction materials, we are going to focus on some of the most important ones that has a major share in construction practice. So let's just get on with it. First, let's start with the basic fundamental. I mean, yeah, before there was glass, before there was concrete, before there was cement, all these are actually man-made. Cement is man-made, glass is man-made, concrete is also man-made. But then, even before all of these, there is a material that has been very primitive, which has been widely adopted in the ancient construction setting. One is, as you might have already guessed it from the slide, it's stone. Typically, stone is a derivative of rock. Let's not confuse rock and stone as two separate construction materials. Stone is a derivative of rock. When you quarry a stone from a quarry, from a rock quarry, you call it as a stone. When you're making a rock quarried from a site, you call it a stone. So when it comes to rock, it is a solid portion which is coming from the earth's crust, and it has no definite shape, and even there is not much of a chemical composition which is very specific. It can be very varying. Sometimes it is more homogeneous, etc. So it's generally very big in size. Since it's coming directly from the crust, yes, it's obviously big in size, and the rocks have one or more materials into them. It can be of a homogeneous material throughout, and it can have more number of different materials clubbed together into a single piece of rock. Next, stone, like I said, it's a derivative of rock. It is always obtained from a rock. A rock quarried from a quarry is called as a stone. So the construction material over here is stone. The construction material is this particular construction material is derived from the rock. So it's naturally available building material. Like I said, it's most ancient, it's very primitive. Since it's naturally available, the construction has construction with stone has been around since ancient civilizations like Greek civilization, Roman civilization, even the Egyptian civilization also used rock for the construction of the infamous pyramids. So quarried stone may be in the form of stone blocks, stone aggregates, stone slabs, stone lintels, stone flags. Yes, you can cut a stone in different pieces into different shapes. Each of these different pieces or shapes will define the category in which it falls. For instance, stone aggregate, stone slab, stone lintel, stone flags. All these are different shapes which are derived from a rock. Next, it has been used as a construction for small residential buildings to large palaces and temples. as you all know, we have the Vidhan Saudar, the Red Fort. All these places are built out of stone. Even the old residential houses which you see, even they are still they were made out of stone. You can still see them here and there in the city out there. So these are the examples. Red Fort is completely made of stone. You have the stone chariot near Hampi, which is completely a monolithic statue, monolithic construction. Next, requirements of a good building stone. Now, it's not that you can take any sort of stone and make it into a construction material. You will have to make sure that it qualifies the minimum standards in order to make it a good construction material. For instance, the stone must be strong against crushing. The minimum crushing strength it should offer is 100 Newton per mm square. That is the minimum strength stone should offer in order to be used as a construction material. Next, the stone should have a uniform color and a decent appearance. Yes, this is of a much more aesthetic perspective. Having a much more uniform color and a much more pleasant look will definitely have an advantage in having that aesthetic perspective for any sort of structure. Next, stone should be durable. It should resist any action against weathering. Like I said, there's huge amount of weathering that is involved in rocks, and these rocks are continuously under some sort stress, which is by the virtue of temperature changes, by the virtue of rain, by the virtue of frost. All these weathering phenomena that might occur on a rock are all the reasons why a rock is undergoing stress. The same thing will apply to the stone as well. So even if a stone is viable for these such sort of stresses that can be happening by the virtue of weathering, stone should be hard enough to resist wear and tear during abrasion action of traffic. Now, wear and tear is about there's something called abrasive property for any sort of a stone. And it's more like a wear and tear resilience to wear and tear. The stone should be able to resist more abrasion in term, and it should be less it should be more resistant to wear and tear in terms of any sort of loads or stresses that are being implied on it. It can be stresses that are by the virtue of traffic. It can be stresses by the virtue of construction buildings, by the construction loads, etc. Next, stone should be free from defects like minor cracks, holes, hollows, small shells, fossils, etc. Now, if you're having a stone which is having a fossil, or if it's having a fissure, a small crack which is inside a particular stone, and when you use that particular stone as a construction material for any building, there's more chances that the stone will be failing in the exact point where the fissure or the crack is present, because having a much more even distributed structure in the stone will definitely give a lot of strength and resistance to oncoming loads. But having any sort of minor cracks or hollows or any sort of fossilized plants which are present in the stone, this will be a weak joint which might be a possibility for a failure to occur. Next, the stone should have a uniform grain with which increases the strength and durability. Uniform grain is about the minor particles which comprises the stone. When you look into a stone, the small grain particles which you see, if it's a much uniform grain size, if the grain size is more uniform throughout the stone, you can expect it to perform well in terms of its durability and strength. But having a different grain size particles, different grain sizes spread throughout the entire stone, the possibility of strength, the possibility of failing in terms of its strength, and the possibility of the wear and tear or abrasion in terms of durability, etc., will not be quite satisfactory. It's more viable for such failures that might occur. Next, the stones are fire resistant. In general, all stones resist fire up to 500 degrees centigrade. So this is a general property of stone by itself. There are stones that are not exhibiting this particular property, but then our motive is to find stones that exhibit a minimum standard of resisting a temperature of 500 degrees centigrade in order to use it as a good building material. A good stone does not contain moisture present. Stones, it's best to have the least amount of moisture present in the stone, because moisture will always have the tendency to weaken the stone or weaken the strength of the stone when present in it. Stone should not be porous. A good stone should not absorb water more than 6% by its weight. Now that's a metric. A good stone, it can be classified as good stone when it doesn't absorb 6% of its dry weight. The weight of the water absorbed should not be more than 6% of its dry weight. Now this is a metric, a standard metric, which classifies a good stone from a bad one. Stone should not be acid resistant and free from any scalable matter. Now resistance to any sort of acids, alkalis, salts that might be present out there in the nature or out there in the atmosphere is something that a good building material should have. That particular resistance is something that a good building material should have, and similarly the stone is nothing different from that perspective. Stone should be acid resistant, should be alkaline resistant, should be resistant to all the atmospheric salts that might be present in the surrounding air. Use of stone. Stone masonry is used for the construction of foundations, walls, columns and arches. Stone slabs are used for dam-proof courses, lintels and even roofing material. Stones with good appearance are used for faceworks of buildings. Polished marbles and granite are commonly used for faceworks. Now, when we talk about faceworks of a building or faceworks, it's basically the material which you see directly. It's something that affects the aesthetic of that particular building. Good stones with a uniform color, uniform grain and a much more homogeneous look can be used as face stones because it exhibits much more pleasing aesthetic look compared to that of stones which are much more non-uniform in nature. Crushed stones stones are also used in construction of piers, abutments of bridges, dams and retaining walls. These are different applications where the stones can be used and had been used previously. Crushed stones with gravel are used to provide base course for roads. Yes, this is a very more recent application where not too recent, but then you use crushed stone as a base course material. For instance, in railways, the stone 40 mm aggregate is used as ballast. Now this ballast, the idea of ballast is to properly transmit the load from the track to sleeper to ballast and through the subgrade of the soil. So stone is used as a course to transmit the loads from the topmost layer to the bottommost layer. Similarly, over here stones are also used as a base course for roads in order to transmit the loads that are happening by the virtue of the oncoming traffic or the ongoing traffic. Crushed stone are used in the following works as well. The basic inert material in concrete mix. Number one, concrete mix has the major amount of material in a concrete mix is basically crushed stone, which is also called as a coarse aggregate. For making artificial stones and building blocks, yes, even stones are used to make building blocks for a much more easier construction practices. Instead of using crude, rugged, rigid rocks, these stones are much more prone to an acceptable, convenient sizes in order to use them as building materials. And as we just spoke, as railway ballast, they can be used as railway ballast as well in order to transmit the loads from the top part to the bottom part. Top layer to the bottom layers of the soil. Right. So this is pretty much about the stones. We have seen its importance. We have seen since when stones have been playing a major role in terms of building construction. The next thing which comes immediately after stone, not something that is primal or primitive, it's much more recent, where some sort of man-made implication is there. The stones are pretty much out there from the nature. They're just cut from the rock. They're just brought onto the into the construction site, and they're just building it directly from the material. There's no any sort of curing, any sort of processing, any sort of manufacturing processes involved in the manufacturing of stone. It's just cutting the stone into appropriate sizes and pieces and bringing it for construction. But bricks, on the other hand, these undergo a proper manufacturing process in order to make them valid for construction. It is one of the oldest building material. Brick continues to be the most popular material even now. Of course, there are different versions of a brick, but then the idea of manufacturing such construction material is pretty much similar. Now, the reason is because brick is very popular amongst the construction industries because number one, it's cheap, it's really durable, and it's easy to handle. When you're trying to handle something with stone, handle something with brick, it's easy because of its weight. Stone is not light in weight. Stone is quite heavy compared to that of a brick. With the same volume equivalent to a stone, if you use a brick for construction, it gives much more lighter weight. I mean, it is of a much more lighter weight. It reduces the amount of dead load that is happening on the building or the self weight of the building, and overall the design is much more efficient compared to that of a brick masonry. Now, clay bricks are used for building up of exterior and interior walls, partitions, piers, footings, and other bearing structures, load bearing structures. A brick is a rectangular in shape, and the size can be conveniently handled with one hand. That is true, and that's why it is used as a wide construction material because of the ease of handling the brick material. The ease of handling a brick is very comfortable. A brick may be burnt of clay or mixture of sand. Brick may be of burnt clay, mixture of sand and lime, or Portland cement or concrete. Like I said, the idea of manufacturing this sort of a construction material is similar, but then the versions of this material is different. For instance, you have clay, burnt clay bricks, you have cement bricks, you have fly ash bricks. You have different versions of brick which has different compositions of materials that are used to manufacture it. Clay bricks are the most commonly used since these are the most economical and easily available. Yes, for clay bricks, all you need is a good standard mud which is qualified to manufacture clay bricks, and that's pretty much it. You just need a kiln or a proper sunburnt region so that the bricks might the bricks will dry. So it's most easily available, it's widely available, and it's the most economical way where you don't need any manufacturing setup in order to have a production line of clay bricks. So we have some metrics over here: the length, width, and the height of the brick. There is a standard, and this standard varies from country to country, and typically the size which we use commonly in construction practices is 19 by 9 by 9 centimeters, and it becomes 20 by 10 by 10 if you're adding 1 centimeter mortar in excess to 19, 9 and 9 respectively. So the length of the brick should always be twice the width of the brick plus the thickness of the mortar, and the height of the brick should be equal to the width of the brick. This is a standard metric which is found in terms of the dimensions of the brick masonry, and this is widely followed in many construction practices, many manufacturing processes. And like I said, the standard size is 19.99 centimeters length, width and height, but there are different countries which have different standards, and this is very application specific as well. Different applications will demand different sizes or dimensions of that particular masonry unit. Advantages over stone. Okay, this is interesting. Stones are not easily available. Yes, you cannot get a good building stone everywhere. Brick, on the other hand, you just need to find a good mud that can be used to make bricks. Next, the size enables ease of handling. Yes, stones cannot be pruned to a size that is easy to handle. Even if it's pruned or trimmed to a size of a brick, it is really heavy and the handling is quite difficult in terms of weight. Whereas brick, on the other hand, even with the same dimensions that of a stone, which is even if it's larger in size, you'll be able to handle the weight of a brick compared to that of stone, because bricks are more lighter in weight. Bricks have a greater fire resistance than stone. Yes, this is also true. Bricks can exhibit a good fire resistance compared to that of stone masonry. Now, constituents of a good brick earth. Now, you have mud everywhere available. Not every mud can be used in manufacturing of bricks. Now, bricks are the most commonly used construction material. Bricks are prepared by molding clay into rectangular blocks of uniform sizes. But then, we need a specific constituents in that particular mud in order to make it qualified for a good construction material. For instance, the constituents of good quality brick is we need silica, alumina, lime. You need iron oxide and magnesium in order to have a good construction grade brick masonry. Now, each of these constituents have different purposes, different uses in the particular brick masonry. For instance, these are the constituents of bricks, and the metric, the percentage of its constituency is also very specific. We need that percentage of that particular constituent in and around that particular range. Otherwise, it might not qualify that particular brick for a construction grade setting. So for silica, it should be 50 to 60% of the constituent of the brick. It prevents cracking, shrinking, and wrapping of raw brick. So having silica in a brick, it definitely has its uses. It imparts more amount of crushing strength. That is the reason why it prevents any sort of cracking that might happen in a brick masonry. Shrinking and wrapping of raw brick is that once the brick is manufactured by the virtue of clay, the wet clay, even when the clay is still wet, during the drying process, there might be a possibility of the brick to shrink, and there might be a possibility of the brick to change its shape around the corners. It's called wrapping. It changes its shape. It doesn't maintain a uniform shape throughout the brick. There is some sort of distortion involved in the brick masonry. Now, excess silica makes the brick brittle. Nothing in too much quantity is advised. So excess silica exceeding 60 to 70%, it will make the brick masonry brittle. That means the brick will break easily. Next, alumina 20 to 30%, it gives the plasticity characteristic of the earth. It means that having more alumina, it will be much more easier to mold the brick into the desired shape. Plasticity is all about moldability. If it's more plastic, the moldability is better. If the plasticity is quite less, the moldability might not be quite comfortable for the manufacturing process to happen. Excess of alumina will cause the brick to shrink, wrap during drying. Just like silica, even alumina in excess will have its effects in terms of shrinking and wrapping. Lime 5 to 10%, it prevents the shrinkage of bricks on drying. It causes silica and clay to melt on burning, and this helps to bind it. So lime has two advantages over here. Number one, it prevents the shrinkage that might happen due to excess silica and alumina. Number two, it acts as this medium that can bind all the materials together when they're put into a kiln or a furnace. It melts because lime produces tremendous amount of heat. This melts and burns all the constituents in that brick masonry unit in order to bind it on a much stronger note. Iron oxide 5 to 7%, it gives the red color in the brick. It's not about the color. The purpose of iron oxide is basically it imparts more hardness, strength. It gives better durability and impermeability. But then red color is a secondary quality that happens because of its presence. Magnesia 1%, it imparts yellow tint to the brick. If the brick is too yellow, you can come to a conclusion that the brick has more amount of magnesia involved. It is responsible for reducing shrinkage. Again, excess magnesia leads to decay of bricks. Decay of the bricks is that brick will not be able to exhibit proper crushing strength. The brick tends to become powdered in terms of excessive load. So these are the constituents of a good brick, and the metrics that are corresponding to the constituents: silica 50 to 60, alumina 20 to 30, lime 5 to 10, 5 to 7, iron oxide and 1% magnesia respectively. These are something that a good brick earth should be able to exhibit. Moving on, classification of brick. Now it's not a hard and fast rule that a brick only having these set of constituents, these specific metrics can be used for constructions. If not, they cannot be used for any such construction activities. It's not in such when it comes to the usage of bricks. We have different classification of bricks, and each of these classifications will define its usability and its application for that particular properties exhibited by that particular class of bricks. For instance, we have three classes of bricks: first class, second class, and third class. The first class bricks are the best bricks out there in the market. It has a high quality to it. It has a greater strength that can be exhibited by it, and these are most commonly used for construction works. And these bricks are table mounted, and they have a very uniform shape. They have sharp edges. They are squared and smooth and straight. I mean, these are one of a kind. They are perfect bricks. And they are also burnt in kilns, and these exhibit the best strength out there. Now, when it comes to the quality, symmetry, shape, and size is all one thing, but the most important thing is the crushing strength a brick can exhibit. Now, for a first class brick, the crushing strength should not be less than 10 Newton per mm square, and the water absorption quality, the water absorption level should be within the range of 12 to 15% of its dry weight. When that brick is immersed in water for 24 hours, the amount of water absorbed by that brick should be somewhere in between 12 to 15% of the weight of that brick when it is completely dry. Now, this is the standard quality of a first class brick. If these are met, we can classify that brick as first class brick, and it can be used for construction practices without any second thought. Next, the uses of first class brick are used for pointing, exposed face work, masonry structures, flooring, reinforced brickwork. All the load bearing structures, the load bearing masonry structures out there, they are all having first class brickwork. It has better resistance to load, it has better resistance to durability aspects, it has better resistance to any sort of wear and tear, and yes, it can be used for constructions that have more load involved in them. Moving on, second class bricks. Now, when we talk about second class bricks, yes, it's not as good as first class bricks, but then there are some problems that are involved with second class bricks. Namely, small cracks and distortions are seen in second class bricks. You don't see that homogeneous uniform dimensions in a second class brick. There is some sort of distortion in terms of its shape, in terms of its wrapping, in terms of the shrinkage. You cannot find those exact book dimensions in these second class bricks. There is some level of deviance. Now, when it comes to water absorption and crushing strength, it is 16 to 20% of its dry weight, which is this is slightly higher than first class brick. If the water absorption is between 16 to 20, we can classify that as a second class. And the crushing strength, the minimum strength it should offer should not be less than, it should be a minimum of 7 Newton per mm square and not less than that, and then only it can be classified as a second class brick. Next, the uses for it is it is recommended for all unimportant and important masonry works, usually hidden from the eye. Any masonry works that is not having a direct visual presence in terms of aesthetics. These can be used for the inner walls which involve complete closures, or these bricks are used for not quite important areas when it comes to the usage or application of such second class bricks. Also, these are also used for centering works for reinforced concrete structures. We can use second class bricks for the centering of any sort of marking that can be done. Also, these can be used for temporary structures as well. If you're planning to have a temporary structure which is of not much of an importance, you can use second class bricks to construct the temporary structure, use it for a while and completely dismantle it later. And lastly, we have the third class bricks. These are completely of a very low grade. These are underburned. These are not even completely burned. They exhibit all sort of inadequacies a brick can exhibit. They are soft, light colored, they produce a dull sound when struck against each other. This production of sound is that we can say that a brick is really good when you can hear a ringing sound when two bricks are struck together. When two bricks are struck together, if you're hearing a ringing sound, it means that the brick is of a good quality. And if you don't hear a ringing sound, if it's much more of a dull, damp sound, it means that the brick is of a much inferior quality. Now, the water absorption is about 25% of its dry weight. That means it has more it has a tendency to absorb more water. If the brick is absorbing more water, you can jump to the conclusion that it will fail in its durability or strength parameters. Now, it is again used for temporary structures, nothing permanent. Something unimportant and temporary is where the third class brick comes into picture. Next, the characteristics of a good brick. Since we have discussed different classes of bricks, we have discussed different constituents of bricks, what are the different constituents and their corresponding metrics that can make a good brick. There are few characteristics that one can identify with naked eye and with on-site presence. You can characterize that into a good or an inferior brick. The first thing is, usually a good brick is copper colored, it's stable, it's well burnt, it's stable molded. Everything is perfect in terms of dimensions, the shape, everything is uniform. It looks quite solid right out of the textbook. But then if you are seeing anything other than this on site, if it's slightly wrapped, it's slightly off shape, or the dimensions are not meeting the exact specifications, it means that it is not a good quality brick. Next, the brick should be uniform in shape and should be of a standard size, like I just discussed. The brick should give a clear metallic ringing sound. Like I said, when you're striking two bricks together, it should exhibit a ringing sound, which is a sign of a good quality brick. The brick, when broken or fractured, should show a bright, homogeneous, uniform, compact structure free from voids. Now, when you're breaking a brick into two pieces and when you're examining the broken fracture, you should be able to see a very uniform grain distribution without any presence of voids or air bubbles or air gaps in it. Now, this is a sign of a good brick, and it can exhibit a better strength and durability, resistance to other durability aspects. Next, the brick should be sufficiently hard. Hardness is about, for instance, to examine this on site, if you're taking a brick and if you're trying to scratch it with something slightly hard, maybe a fingernail or maybe a nail, the brick should be able to withstand that scratch. I mean, it should not be exhibiting any sort of marks of that particular scratch. Only then you can say that the brick is actually hard. The hardness index is basically based upon this particular phenomenon where you scratch a particular material with different materials of different hardness index, and this is also one application, this is also one test you can conduct on a good quality brick. When you can call a good quality brick as a hard brick, a sufficiently hard brick, only when it doesn't show any sort of impression when you're scratching it with your nail or any hard object. A brick should not break into pieces when dropped flat on the ground. Now, when you're taking a brick and dropping it from about a height of 1 meter onto the floor, it should not break into pieces. Now, this is one simple way of identifying a good quality brick from an inferior one. The brick, when soaked in water for 24 hours, should not deposit any salts when dried. Thing is, there's something called efflorescence in materials. Efflorescence is all about the soluble salts that are present in the materials will eventually surface up to the topmost part on drying or over time. This exhibition of efflorescence should be completely void in terms of brick masonry, and this should not happen, because if so, it means that the brick is having a high absorption rate and it has absorbed a lot of salts, or it has many dissolved salts in the brick material, in the brick meal. We call the manufacturing material as raw meal. In that constituents, you have a lot of soluble salts, which is not advisable for a good brick masonry unit. No brick should have a crushing strength below 5.5 Newton per mm square. Now this is the minimum cutoff. You cannot afford to have a strength lower than 5.5 Newton per mm square. This is a minimum standard where a brick should be able to exhibit in terms of its use in construction practices. Next, cement. Now cement is it's basically a binding material. It's not like a material that can be used for construction by itself. Yes, it can be used, but then mostly cement is used as a binding material when it comes to construction activities. Most of the construction activities, cement when it is molded and when it is cast, and once it hardens, it exhibits that solid bound material property that can withstand any sort of loads that are being applied on it, or it can withstand any sort of durability aspects that might occur on it. Cements used in construction industry may be classified as hydraulic and non-hydraulic. These are the two main categories of cement, hydraulic and non-hydraulic. The non-hydraulic will not set and harden in water, such as non-hydraulic lime, or which are unstable in water. Plaster of Paris. Plaster of Paris is a typical example of a non-hydraulic cement, more of lime content in it. Hydraulic cements set and harden in water and give the product and give a product which is stable. Now your cement which has been used widely out there is a hydraulic cement, and when cement comes in when it comes in contact with water, it eventually hardens and it exhibits a much more stable material. Now this is not the case with non-hydraulic cement. That's why plaster of Paris is very weak in terms of its strength. Now, important properties of cement. There are 5 important properties which can usually be seen in any cement out there, hydraulic or non-hydraulic. The fineness of the cement is about the particle size in which a cement is comprised of. If the particle size is uniform throughout, it means that it has a very good fineness. The cement is much more uniform in terms of its fineness. It has a significant impact in on the strength aspects as well. Soundness of the cement. Now the thing about cement is that when the cement is mixed with water and when it is left to dry, on drying the cement has a tendency to shrink. The given size of that particular cement brick or cement mold on drying will have the tendency to shrink. Now this shrinking when the cement hardens over time is called the phenomenon is called the soundness. You can say a cement to be sound if it is exhibiting less amount of shrinkage. Lesser the shrinkage, better the sound of the cement. If you can call a cement an unsound cement if the shrinkage is much more higher. Sound is not a word in terms of audio, but then sound is a term of quality over here. More shrinkage, unsound cement. Less shrinkage, sound cement. Consistency. Now the ability of the cement paste to flow is called consistency. Now we need workable cement. Cement should be workable so that it can be changed, it can be made into different shapes, it can be applied to different corners and different fractures. Now the consistency is the amount of flow that paste can exhibit. If the cement paste is more flowable, we can say it as it's more consistent in terms of its workability. Strength, like I said, cement mortar also has a strength which is directly related to the overall strength of the structure. Setting time, the time taken to become hard or lose its plasticity is called setting time. Different cements have different setting time. We have different applications for a delayed setting time or a quick setting time. So that's something of a much more deeper note. But in general, as an important property of cement, setting time will also play a major role in defining the hardness or the strength or the application of that particular cement or structure. Now applications of cement mortar for masonry works, plastering, etc. Concrete for laying floors. These are the different applications which you are seeing over here. These are the different places where you get to use cement mortar, not just limited to these points over here. The cement has more applications out there. construction of important engineering structures like bridge, culverts, dams, tunnels, etc. Making of joint pipes, etc. Construction of water wells, tennis courts, septic tanks, lamp posts. The list goes forever. Manufacturing of precast pipes, garden seats, aesthetically designed wells, flower posts, etc. Even those seats which you see in the park, they are completely manufactured with cement, reinforced cement. Preparation of foundation, watertight floors, footpaths, etc. These are other applications when it comes to the usage of cement. Concrete. Now, we have discussed aggregate, we have discussed cement. Concrete is more or less a mixture of aggregate and cement. You have two different types of aggregate: a coarse aggregate, which is stone, a fine aggregate, which is sand. And when you mix cement with stone and sand, with the presence of some water, it becomes concrete. Concrete is a composite material composed of cement, coarse aggregate, and fine aggregate and water. Like I just said, cement and water form a paste that hardens a bond on all the aggregates together. Cement is a binding agent over here. Over time, cement forms a hardened matrix which binds with the rest of the ingredients together into a durable stone-like material. And that's and that is the reason why concrete is the most versatile material, construction material out there, because of its ease of manufacturing, its ease of work placing, its ease of making into different shapes. That's why we call concrete as the most versatile construction material. The aim of the mix, the aim is to mix these materials in measure amounts to make the concrete that is easy to transport, place, compact, finish, which will set, harden, and give a strong, durable product. Like I said, concrete being a most versatile material, the reason is being that it should be able to be transported, placed, compacted, finished, and when it is hardened, it should be able to exhibit a good amount of strength and durability. If concrete is reinforced with steel, it is known as reinforced cement concrete. If you are having steel rebars or steel elements inside normal cement, plain concrete cement, you can call it as a reinforced concrete cement. Now, basic properties of concrete. There are three basic properties of concrete. Number one is workability, the ease with which the concrete can be placed and finished. Now, once you manufacture or once you make concrete, that is nothing but mixing sand, sandstone, cement, and water together, the ease with which you mix all these three, mix all the ingredients and place it on your site, in your site, and finish it is called as workability. The more easier the placement and the finishing is, the more workable the mix, the cement concrete mix is. Strength, resistance to withstand external load, like the name itself depicts, it's the resistance to withstand any sort of external stresses that are applying or being applied on that particular material. Durability, to withstand the condition for which it has been designed without deterioration. Okay, durability, deterioration is a good word that can summarize durability aspect. Now, deterioration usually happens over time, and durability is also seen over time. Deterioration can happen with various reasons. It can be due to weathering, it can be due to temperatures, it can be due to constant loading, it can be due to cyclic loading. There are numerous reasons. It can be even due to the atmospheric constituents that are present in the atmosphere, all the soluble constituents, soluble salts, the atmospheric salts that are present, the water to which that particular material is exposed, the constituents of the water to which the particular material is exposed. All these aspects define the durability of that particular material. Uses of concrete. Concrete is most commonly used construction material. It is the most versatile construction material. It is used in heavyweight and lightweight concrete. It is used in buildings, dams, bridges, and even highways. Advantages of concrete. It is durable, cost-effective, widely used construction material, sustainable for residential and commercial projects. The strength of the concrete increases over time. Now, this is a very important property of concrete. Concrete increases its strength. It exhibits more amount of strength with age. That is the reason why when you try to test concrete cubes at 3 days curing time, at 7 days curing time, at 14 days curing time, and 28 days curing time, you can see the increment of strength gradual over the time, over the increase of time. If its superior structural integrity provides resistance against weather, fire, and earthquake, the resistance against any weather, fire, earthquake, or natural calamities, concrete exhibits better superiority over other materials. It can be shaped in various forms and freshly mixed state. Like I said, its versatility in becoming into different shapes, in molding into different shapes, is really high, and hence it has been concluded as a really good construction material. Concrete gives a longer service life compared to that of steel, compared to that of wood. Concrete will definitely give a longer life to any building. Steel has a tendency to corrode. Timber or wood have a tendency to rot by the virtue of any sort of organic matter. Aluminium will also corrode, but concrete, on the other hand, being an inert, mostly inert material by itself, it doesn't exhibit the properties of corrosion or erosion over time. But then the durability aspect is also something to look upon when it comes to concrete, and this can be seen at different levels on a much more deeper context. But in general, as the advantages of concrete are concerned, these are the primary ones in which this particular building material is advantageous over others. With this, we'll be concluding today's session on building materials. Thank you. My name is Ratnatej Reddy. I'll see you again in next session. Bye.